Okay, so for this first question, they're asking you how many liters, so I know that my final answer is going to have liters, are in 56 grams. So I'm starting off with 56 grams. They put it right here for me. At STP, anytime that they say STP, that means that 1 mole is going to equal to 22.4 liters. That is always my conversion for standard temperature and pressure for gases. Okay, so I have grams here. My answer does not have grams. So I need to cancel out my grams, so I need to have grams at the bottom. The only other conversion that has grams in it is grams per mole. Remember, grams per mole. And that means I have to find the molar mass of whatever I'm talking about. So the molar mass of helium is 4.003 grams per mole. That's the molar mass of helium. So for every 4.003 grams, I have 1 mole. 4.003 grams per 1 mole. That is a molar mass of helium. So now I have canceled out my grams, and I am with moles now. My final answer still does not have moles, it only has liters, so I know that I have to put moles at the bottom to cancel it out. The only other one that has both units, moles and liter, is this one right here. So 1 mole is equal to 22.4 liters. 1 mole is equal to 22.4 liters. And now I have effectively canceled out my moles, and the only unit I have left is liters, which is what I wanted. So now I just have to do the math and solve it. So 56 times 22.4, because they're right next to each other. And then that number divided by 4.003. And that is going to be 313.36. I have to round to the hundredth. That was the instruction. So that was my answer. I gathered all of the units. I canceled them out using my conversions. Okay, so number 2, or the next one. So they're asking me about the mass. What is the mass? So I know that my final answer has to have grams in it. And then I start with 5.0 times 10 to the 23rd atoms. I start with atoms. I know that one of my conversions is that for every 1 mole, I have 6.02 times 10 to the 23rd atoms. I know that this conversion is the only one that has atoms in it, so I'm going to use it. So I know that I need to put atoms at the bottom to cancel out my atoms at the top, and that means that moles have to go at the top. So now I'm just gonna fill it in. So for every 1 mole, I have 6.0 times 10 to the 23 atoms. So now I have effectively canceled out my atoms. Atoms go away because it's at the top and the bottom. And now I'm only dealing with moles. But again, my final answer has grams. And the only other conversion that has grams and moles is this one. And that means I have to find the molar mass. Molar mass again. Woo! Molar mass of potassium. If I look at the periodic table, the molar mass of potassium is 39.098 grams per mole. So now I can go and fill it in. I know that moles have to go at the bottom, so I can cancel out the moles at the top, and therefore grams have to go at the top. So I have 39.098 grams per mole, per 1 mole. Now I have canceled out my moles because I have them at the top and the bottom. I have grams left over, which is what I wanted, and now I just have to multiply and divide whatever I have. So 5 times 10 to the 23rd times 39.098 is equal to a number and that number has to be divided by the bottom because this is at the bottom. So divided by 6.02 times 10 to the 23rd, and my final answer in grams is 32.47, rounded to the hundredths place. And that's how you do those two problems.